today we're going to talk about thermochemistry and reactions. Last time we talked about enthalpy in stoichiometry. And we talked about finding the enthalpy of a reaction. We did some math. We know that this particular reaction here, for instance, gives off 906 kilojoules. So if that and that's if you start with 4 moles of ammonia. So if you do 8 moles of ammonia, obviously you're going to give off twice as much. All right. Now, where does this value come from? Where are these values that we're using coming from? Well, you can look these up in tables. There's a table in the back of the book you can look it up on if you had a physical book. You can look it up online. In your notes, I think I included a table. I have sheets at school that are in plastic protectors that normally I would pass out for you to use. So these are things that we've studied the energy enough, we can look them up in tables and we get that enthalpy. All right? But not always does enthalpy or does a reaction happen that you can look up the energy. Sometimes it happens in steps. All right, so we're going to start the online book, section 7.8. That's where I'm getting this information from. If you want to open that book and follow along with that, I really wish I could get you a physical book for this. I can't. I can get you books. If you want a book, I can go up and get the old book, JUCO book, and you can have it because we don't use those anymore. If you want one, just to email me. All right, enough of that. All right, so the first thing you have to understand when we're talking about the enthalpy of a reaction, notice RXN, is that if a chemical reaction equation is multiplied by a factor, you're going to multiply that enthalpy as well. So if we have 2 carbons and 2 oxygens producing 2 carbon dioxides, then we're going to take 393.5 times 2, which is negative 787 kilojoules. Okay, that's a pretty simple concept. If we reverse a reaction, well, if a reaction is giving off energy and reverse it, it's going to take in energy. So we change the sign. So on this guy, we would change, if you compare this guy, this is the same reaction we have up here, but it's reversed. Okay, see there's the carbon dioxide, there's the oxygens, there's the carbon, and now we have a plus sign for our enthalpy. All right, so if we multiply a reaction, we multiply the enthalpy. If we reverse a reaction, we reverse the enthalpy, or change the sign on the enthalpy. The third piece of this is if you have multiple steps, you can put those together and you get, all you have to do is add up the enthalpies then, and you can get the enthalpy of the reaction. If you don't know the enthalpy of the whole reaction, but you know intermediate steps. For instance, if we have reaction A plus 2B gives you C, and it has an enthalpy associated with it, and we also know that C will give you 2D. If we want to know the reaction for A plus 2B gives us 2D, you'll notice that the C's cancel each other out, and we can just add those together. Now, this will make much more sense once I do one. All right? So, well, this first one is just this concept of doubling the reaction. If we've got, here's our reaction, 2A plus B gives us C. And we want to know what the enthalpy is for this reaction. Well, first of all, notice that's reversed. So it's going to be negative 122 kilojoules because the C went to the other side, and it's been doubled. So we need to double it as well. So that would be negative 244 kilojoules. Okay? Next one. if this is our reaction, and these are the pieces that make it up, what we have to do is put these together, and it becomes a puzzle. I think this is why I like Hess's law so much. And if we were at school, I have, for examples, I have manipulatives where you can manipulate. I can't do that here with you. I'm sorry. But you could make your own out and manipulate them. I can do this. I can... No. I can do this. No? Just make my pointer. I can move things around on this, so you'll be able to see that. Okay, so what we have to do is figure out where all these pieces are. Okay? Carbon is right there. It's on the reactant side on both the complex reaction and the simpler ones. Water. Here we have water on the product side. We don't have any water anywhere else. It needs to be on the reactant side because in our equation it's on the reactant side. So we're going to have to flip this. So we're going to write 2H2O 2H2 plus O2, and we're going to change that sign. Okay, so we've got water, we've got carbon so far. Let me get my highlighter back out. Well, water's on the right side. Now let's look for carbon monoxide. Carbon monoxide is here, but it's on the left side. So we need to flip this around. So we're going to go 2CO2, because I'm using this, will decompose into 2CO plus O2, which means I'm changing this to 566 kilojoules. All right. Now we're going to look for CO. So our CO is on the right-hand side. Now we need hydrogen on the right-hand side, and I have hydrogen on the right-hand side. Okay. All my pieces of my parent reaction are there. Now I've got to make sure they all add up. Okay, this guy is carbon, one carbon, we're good. This guy, water, there's one here, but there's two down here. Okay, if we can multiply reactions, we can also cut them in half. So if we divide this whole guy in half, we would divide that number in half. Okay, so now we have one water, we're good. The next one, carbon monoxide, also a situation. We have two in our simpler equations. Our complex equation only has one, so again we're going to divide all these in half. And our carbon, and this guy's going to get divided in half. I'm going to have to write it out here because I don't have room. And then finally, let's see, our hydrogen's now 1, so our hydrogen's okay. Now we add them up. So we have negative 393.5, 566 divided by 2 is negative 283. Oh, no, it's positive, though. And 483 divided by 2 is 241.8. So now I add these together. 283 plus, oh no, we're going to subtract, minus 393.5. So I've added this one, and then subtracted that. And my total is 131.3 kilojoules. Okay, so I've rearranged my equations so that they create the complex equation. All right, the next one, same story. Okay, we start with 3 carbons. We have a carbon here. There's only one, so I'm going to multiply everybody in this one by 3. We have 4 hydrogens here. There's only 2 here. So we need to multiply everybody here by 2. So 2 times 2 would be 4. C3H8 is on the wrong side. So I'm going to reverse that reaction. So this is going to become a positive, and I'm going to have 4H2O plus 3CO2 gives us C3H8 plus 5O2. Okay? Now let's make sure everything cancels out. We've got 3 carbons, 4 hydrogens, 1 propane, 1 propane. Everything else should cancel out now, whether we go through the process or not. But let's go through the process. 4 waters. On each side, they cancel themselves out. 3 carbon dioxides, 3 carbon dioxides. On both sides, they cancel each other out. 3 plus 2 is 5 oxygens, they cancel out. Now we just add these guys up. So I start with 2043 minus 3 times 393.5 minus 2 times 483.6, and I get negative 104.7 kilojoules. The third one, same story. We've got N2O. Here's N2O, but I have 2 in that equation and I only need 1. So I'm going to divide it by half. So I'll basically multiply everything by 1/2. So that makes that one, and this will be 1/2. Alright, NO2. NO2 here is on the product side. It needs to go to the other side. 2NO2 gives us 2NO plus O2. We've moved him around, so he's got to become positive. NO2's here, but we only need 1, so we're also going to multiply that guy by 1/2. So that gives me 1 here, and 1/2 there. And then we need 3 NOs. We've got 2 NOs here. Now here's the dilemma. How do I go from 2 to 3? Well, if I have 2 NOs and I want 3, if I multiply everything in this reaction by 3/2, then I'll end up with 3. So I'm going to go 3/2 N2, 3/2 O2, 3/2 gives me 3, and I have to multiply that whole thing by 3/2. Okay, so first I'm going to take 113.1 divided by 2, 56.55, 182.6 times 3 divided by 2, multiply it by 3/2, is 273.9, and then negative 163.2 divided by 2 gives me negative 81.6. Add those all up. And 248.85 kilojoules. You don't have to worry about sig figs here. Alright, here we go. 3 hydrogens. We have 2 hydrogens. We're going to multiply that guy by 3/2. Everybody in that equation by 3/2. Okay. Ozone, O3. Wrong side, so I need to flip these 2 guys around. So 2O3 gives us 3O2. So this is going to become negative 285.4. And I just need 1, so I'm going to multiply everything in this one by 1/2. So this guy's good now. 3 waters, we have 3 waters. So we just need to add it all up. So I'll do this guy first. 400 negative 483.6 times 3 divided by 2 gives me negative 600.975. The second one, negative 285.4 divided by 2 gives me negative 142.7. I add them together. And I get a total of negative 743.675. All right, try, it says Hess's Law in the assignments. Try that on your own and see how we do, and then let me know. Thanks.